Hello, my learners. Let's solve this science problem with ease. Okay, so there is an electrical circuit diagram on the board, and then we have our battery here that is 6 V. We have the ammeter, and then we have the two resistors here that has been arranged in parallel. So this is in parallel connection. Okay, so we should calculate the effective resistance in the circuit when it is closed. So when it's closed, when the circuit is closed, it means current is flowing through the circuit. Okay, so effective resistance of the resistors here. Okay, so this one, let's say this one is resistor 1, this one is resistor 2. So let's calculate the effective resistance. So resistor 1, that is R1, is 4 ohms. 4 ohms, and then the symbol is something like this. And then resistor 2, this one is 5 ohms. So the resistor 2 is 5 ohms. Okay, so the formula for calculating effective resistance when it's arranged in parallel connection is 1 over R to be equal to 1 over R1 plus 1 over R2. Since we have two resistors, that is why we ended at R2. If we had 3 resistors, it will be plus 1 over R3, but the resistors, they are 2, so you end at R2. Okay, so now let's substitute the information into the formula and find the effective resistance. So this gives us 1 over R to be equal to 1 over R1 is 4 ohms. So that is 1 over 4 plus 1 over R2, resistor 2 is 5 ohms. Okay, so this is fraction. We find the LCM. So LCM of 4 and 5 is 20. So it gives us 1 over R to be equal to LCM, which is 20. 4 goes into 20 5 times, 4, 5, 20. And then 5 times 1 is 5, so we get 5 here. Plus 5 goes into 24 times. 4, 1, 4, so we get 4 here. So 1 over R will be equal to 5 plus 4, which is 9 out of 20. So we want R, not 1 over R. So you reciprocate it. So when you reach there, you reciprocate it. Then you get R over 1. R over 1 is R, which is equal to, then this one also reciprocates, we get 20 over 9. So the final answer is 20 over 9 ohms. Or you can change it to mixed numbers, which will give us 9 goes into 22 times. That is 9 times 2, 18. So 2 times remainder 18. So 18 remainder 2. In order for us to get to 20, so 18, and then 19, 20, so remainder 2. So remainder 2 over the denominator here, which is 9. So the final answer is 20 over 9, or 2 whole number, 2 out of 9 ohms. So resistance is measured in ohms. So the effective resistance, or the total resistance across the circuit is 20 out of 9 ohms, or 2 whole number, 2 out of 9 ohms. Okay, current that will flow through the circuit when it is closed. Current that will flow through the circuit when it is closed. So current. So from Ohm's law, we know that voltage equals current times resistance. So from Ohm's law, we know that voltage equals current times resistance. Okay, so we want to calculate current. So let's make I the subject. So making I the subject, which is current, so we can divide it by R. Then we divide it also by R. So that R cancels R, then we get I, which stands for current. So I will be equal to voltage over resistance. Therefore, current equals voltage over resistance. Now let's substitute the values into the formula and find current. Okay, we can say therefore current is equal to, so voltage, from the question, the voltage is says V, that is the battery, says V. So the voltage is 6 over resistance. So we just calculated the resistance. So the resistance is 20 out of 9. So meaning if you calculate this one wrong, automatically you also get this one wrong. So the resistance is 20 over 9. So 6 divided by, let's do it like this, 6 divided by 20 over 9. So 20 out of 9. Now let's solve it. We can say I current is equal to, so fraction, this one changes to multiplication and then this one reciprocates. So we get 6 times 9 out of 20. Okay, so we get current equal to, so let's cancel it out so that it becomes easier for us to solve it. We know that 2 can go into 6 and at the same time goes into 20. So 2 goes into 6 3 times. So 2, 3, 6. And then 2 goes into 20 10 times. We get 3 times 9. So 3 times 9 is 27. So 27 over then 10 here to 27 out of 10. Okay. So let's change it to decimals. Yes, let's change it to decimals. So we have 1 0 here. So we can count from the back. Since we have 1 0, counting from the back, we have the point to be here. So 27 divided by 10 gives us 2.7. Yes, 2.7. Since we have 1 0, you count from the back 1, and it will be here. So we have 2.7, and then current is measured in ampere. So 2.7 ampere. So if you found this one helpful, like, comment, and share for your friends. Thank you.